Every rocket company burns kerosene or hydrogen. SpaceX shows up with methane and absolutely destroys them. Traditional engines are covered in toxic soot after each flight. Raptor engines? Spotless inside after firing. Methane just humiliated every rocket fuel on Earth. Here's how they did it. Let's dive right in. But here's what everyone missed. SpaceX wasn't just changing fuel. They were about to embarrass every rocket company on Earth. Picture this scene from 2010. NASA engineers are celebrating another successful space shuttle mission, but behind closed doors, they're dealing with a nightmare nobody talks about. Every single hydrogen-powered engine requires massive cleanup after flight. The fuel is so cold it could literally freeze your oxygen supply solid. Storage tanks need insulation thicker than your car. And if anything goes wrong, the entire system becomes a ticking time bomb. Meanwhile, Boeing and Lockheed Martin are burning kerosene in their rockets. Sounds simple, right? Wrong. After every flight, toxic black soot coats the inside of their engines like tar. Engineers spend days scrubbing this garbage out with industrial cleaners. It's like trying to clean a chimney that's been burning dirty coal for hours. But here's the kicker. Everyone in the industry knew these problems existed. They just accepted them as the cost of doing business. Then SpaceX shows up with methane and changes everything overnight. When SpaceX announced Raptor would burn methane, rocket engineers literally laughed. "Those Tesla guys don't understand rockets," they said. "Stick to making cars." Big mistake. The first time a Raptor engine fired, something impossible happened. After the test, engineers walked over to inspect the engine. They looked inside the nozzle, expecting the usual mess. Nothing. Completely spotless, like it had never been fired. How is that even possible? Remember, this is an engine that just burns several tons of fuel in seconds. Traditional engines would be coated in residue. But methane? It burns so clean it's like it disappears. Think about your kitchen stove. Natural gas burns clean. No smoke, no soot. Now imagine that same clean burn, but scaled up to produce enough thrust to launch a skyscraper into space. That's when the industry realized they had a problem. But clean burning was just the beginning of methane's secret weapons. Here's where it gets technical, but stick with me because this changes everything. Every rocket fuel has a boiling point, the temperature where it turns from liquid to gas. Keep fuel liquid, and you can store massive amounts in small tanks. Let it turn to gas, and you need warehouse-sized containers. Hydrogen boils at negative 423 degrees Fahrenheit. That's colder than the surface of Pluto. To store hydrogen, you need insulation systems that make a thermos bottle look primitive. NASA spent billions perfecting these systems, and they still lose fuel to boil off constantly. Kerosene, on the other hand, stays liquid at room temperature. Easy to store, but remember that toxic soot problem? Methane boils at negative 259 degrees Fahrenheit. Still cold, but here's the genius part. Liquid oxygen boils at negative 297 degrees. They're close enough that you can store both fuels in adjacent tanks sharing a common wall. SpaceX's engineers realized they could eliminate half the complexity of rocket fuel storage with this one choice. While NASA was building elaborate insulation systems, SpaceX was designing simpler, lighter tanks. But wait, it gets better. Now here's where SpaceX did something that seemed impossible. They didn't just pick better fuel. They built an engine type that had never successfully flown in history. Traditional rocket engines waste fuel. Here's why. To pump fuel into a burning rocket engine, you need pumps powered by burning fuel. It's like using gasoline to power the pump that fills your gas tank. Most of that pump fuel gets thrown away after doing its job. SpaceX said no more waste and designed something called full-flow staged combustion. Instead of throwing away the pump fuel, they capture it and feed it back into the main engine. Zero waste, maximum efficiency. Only 2 other engines in history had attempted this design. The Soviet RD-270 never flew. Aerojet's version never left the test stand. Both failed because the engineering challenges seemed impossible. Why? Because full-flow staged combustion creates temperatures and pressures that would melt most metals on Earth. We're talking about conditions more extreme than Venus. SpaceX didn't just solve this problem, They made it look easy. Here's the part that sounds like science fiction. To make Raptor work, SpaceX had to invent entirely new metals. The engine's pre-burners operate at over 800 bar of pressure. That's like having the weight of an 8-kilometer tall column of water pressing down on every square inch. Venus, the most extreme planet in our solar system, only has 93 bar of atmospheric pressure. During development, dozens of Raptor engines literally melted. Test stands were destroyed. Combustion chambers exploded. Elon Musk revealed SpaceX developed their own superalloy called SX500. They basically became metallurgists just to make their rocket engine possible. Think about that for a second. SpaceX didn't just build a better engine. They had to invent new materials science to make it work. But here's where the story takes an incredible turn. SpaceX wasn't just building a rocket engine. They were solving humanity's biggest space problem. Traditional rockets are like expensive fireworks. Use once, throw away. The space shuttle engines were the only reusable engines in history, and they flew maybe 30 times each before major overhauls. SpaceX set an impossible goal, 1,000 flights per Raptor engine. This is where methane's clean burning became absolutely critical. Kerosene engines accumulate that toxic soot with every flight. After each use, you need extensive cleaning, part replacement, and careful inspection. It's like trying to reuse a chimney that gets dirtier every time you light a fire. Hydrogen engines require complex ground systems and careful handling. The fuel is so difficult to work with that turnaround times stretch for weeks. Methane engines? SpaceX proved they can literally be refueled and flown again within hours. Ground tests showed Raptor engines firing repeatedly with zero maintenance. The inside remained as clean as the day they were built. This isn't just better technology. It's the difference between space travel being impossibly expensive and affordable for everyone. Now here's the twist that made every other space agency realize they'd been playing the wrong game entirely. Every Mars mission in history faces the same fatal problem. You need fuel to get home, but you can't carry enough fuel for a round trip. The rocket equation is brutal. More fuel means bigger rockets, which need more fuel, which need bigger rockets. It's an endless loop that kills missions before they start. But SpaceX discovered something incredible about Mars. The planet's atmosphere is 95% carbon dioxide. There's water ice at the poles. With a simple chemical process called the Sabatier reaction, you can convert CO2 and water into methane and oxygen. SpaceX didn't just pick a better rocket fuel. They picked the only fuel you can manufacture on Mars. While NASA plans one-way missions, SpaceX is designing a fuel system that turns Mars into a gas station. They're not just planning to visit Mars, they're planning to commute there. Think about the implications. Every other space agency is stuck with fuels that only exist on Earth. SpaceX chose the one fuel that exists everywhere humans might want to go. Here's where this story gets even more mind-blowing. The original Raptor engine looked like a mechanical nightmare. A dense forest of pipes, valves, and components that engineers called the Christmas tree. Raptor 2 was completely redesigned. Hundreds of bolted connections became seamless welds. Complex manifolds disappeared entirely. Then came Raptor 3. When SpaceX first showed it, rocket industry experts didn't believe their eyes. Tory Bruno, CEO of United Launch Alliance, claimed it was only partially assembled. He was dead wrong. It was just that advanced. SpaceX followed a ruthless philosophy. The best part is no part. Each version eliminated components, simplified design, and improved performance. Raptor 3 produces 280 tons of thrust, more than any operational engine in history, while weighing less than its predecessors. It's like building a sports car that's more powerful, lighter, and simpler than the economy car it replaced. But how did SpaceX achieve such dramatic part reduction? The answer reveals why they're years ahead of everyone else. Many components weren't eliminated. They were integrated using advanced 3D printing. Those straight pipes you see? They contain most of the smaller pipes and cables from before. You just can't see them anymore. SpaceX developed what Musk calls the world's most advanced 3D metal printing technology. This allows them to manufacture cooling channels directly inside engine walls, eliminating the need for external heat shields entirely. Traditional rocket companies are still building engines like 1960s carburetors. Lots of separate parts bolted together. SpaceX is building engines like modern computer processors, everything integrated into unified components. Let's put SpaceX's achievement in perspective with some jaw-dropping comparisons. NASA's RS-25 engine achieves 452 seconds of specific impulse, the gold standard for efficiency. It costs approximately $146 million each and took decades to develop. SpaceX's Raptor 3 achieves 350 seconds of specific impulse, only 22% less efficient, while costing a tiny fraction and being manufactured at over one engine per day. The space shuttle carried 27 tons to orbit using the most advanced technology of its era. Starship will carry 150 tons using engines that cost less and fly more often. Boeing's SLS rocket costs over $4 billion per launch. Starship aims for under $10 million per launch, a 400 times cost reduction while carrying 5 times more cargo. These aren't incremental improvements. This is like comparing a horse-drawn carriage to a supersonic jet. While SpaceX was perfecting methane engines, what was everyone else doing? NASA continued pouring billions into hydrogen technology. Blue Origin started developing methane engines, but couldn't solve the full-flow stage combustion challenge. Boeing and Lockheed Martin stuck with the same kerosene and hydrogen combinations they'd used for decades. The result? SpaceX now has operational engines that outperform anything else in existence, while their competitors are still trying to catch up to technology SpaceX mastered years ago. It's like watching Formula One cars show up to a horse race. The competition isn't even in the same century. SpaceX's methane revolution triggered something unprecedented, an entire industry transformation. Blue Origin scrambled to develop their own methane engine, the BE-4. Relativity Space designed their entire rocket around methane. Even established companies like ULA had to abandon their planned hydrogen upper stages and switch to methane alternatives. The fuel everyone ignored for 60 years suddenly became the industry standard. But here's the kicker. SpaceX had a multi-year head start and the only operational, full-flow, staged combustion engine in history. By the time competitors realized what was happening, SpaceX was already manufacturing engines that made their best efforts look primitive. Today, SpaceX's Raptor engines power the most powerful rocket ever successfully flown. Starship has already demonstrated capabilities that seemed impossible just a few years ago. But the real revolution isn't just about better rockets. It's about making space accessible to everyone. With Raptor engines, SpaceX can launch massive payloads for a fraction of traditional costs. They can refuel in orbit. They can manufacture fuel on other planets. This isn't just improved rocket technology. It's the foundation for becoming a spacefaring civilization. And it all started because SpaceX had the courage to choose the fuel everyone else thought was too difficult to master. While the industry optimized the past, SpaceX built the future. So here's what just happened. SpaceX didn't just pick better fuel. They completely rewrote the rules of space travel. While everyone else was perfecting yesterday's technology, SpaceX built tomorrow's rocket engine. But here's the crazy part. This methane revolution, it's just getting started. Think about it. We're watching the first rockets that can refuel on Mars, the first engines that can fly 1,000 times, the first fuel choice that makes space travel affordable for everyone, not just governments with billion-dollar budgets. And if SpaceX can do this with rocket fuel, what else have we been doing wrong? What other impossible problems are actually just waiting for someone brave enough to ignore what everyone else thinks is normal? The real question isn't whether SpaceX will get to Mars. It's what happens when an entire generation grows up thinking that reusable rockets, space manufacturing, and interplanetary travel are just normal. What breakthrough do you think will shock the world next? Because something tells me SpaceX isn't done surprising us yet. This weighs less than a car, but it's 3 times more powerful than the engine that took us to the moon. How is this even possible? SpaceX just shocked NASA with their Raptor 4 engine, 330 tons of thrust packed into just 1,500 kilograms. This thing runs at 3,000 degrees Celsius. That's hot enough to vaporize steel instantly. By every law of physics, this engine should explode. But it doesn't. It works perfectly. What makes this impossible engine even possible? Let's dive right in. Here's something that will blow your mind. 5 years ago, SpaceX's first Raptor engine was a 2,000-kilogram monster that could barely push out 185 tons of thrust. Today, they've built something that weighs 25% less, but produces nearly double the power. How is that even possible? The answer lies in a philosophy that NASA thought was insane. Instead of spending decades perfecting a design on paper, SpaceX builds, breaks, and rebuilds. They've literally blown up hundreds of engines just to learn how to make them better.